Hello everyone. Welcome to the introductory session on Fundamentals of Business Analytics, a course offered by the SkillSpeed organization. What we intend to do with this session is to give you a quick overview to the course, which will help you understand the relevance of analytics in today's world and how this course is important stepping point for your journey in analytics. Before we begin the session, I would like to introduce myself. I'm Kalpana Subramappa, and I am the SME for this course. I am a fairly senior, consultant in analytics space, and I am also an educator. I have a mix of both corporate and academic experience. I worked in companies like Genpact, G Capital, G Plastics, and Steel Authority of India. In Genpact, my primary role was I used to lead a team of 50 analysts that had the function of doing projects in the area of decision science. I was also based out of US, working for one of the major automotive finance companies, setting up their analytics practice. I'm also a Six Sigma black belt and a certified Six Sigma trainer. I hold a master's degree from IIIT Bangalore and electrical and electronics engineering from Mysore University. Apart from work, you can see my other hobbies are I'm a professional storyteller, and you will see that in all my presentations I will bring some element of storytelling and make it interesting for you. I'm also an avid traveler. I will be there throughout the entire program to help answer any of your queries related to the course, and I will bring in my expertise in the industry to help you get started on your career in analytics. So why analytics? Analytics is no longer a buzzword. It's actually, there's a loud sound and noise about it, and it's no longer a buzzword. It's out there. And why do you think this has happened? Why is analytics suddenly taking such an importance? Over the last decade or so, the information age has come to a mature level, and there is explosion of data everywhere. Organizations are amassing data. They are collecting and capturing data in large volumes. So this could be data from as simple as the barcode on the bread you bought, or it could be a device sitting on a remote location which is sending data about the functioning of the device. So there is an explosion of data, and the key challenge to everyone is that storage of the data is easy, but what does one do with the data? How does one get insight from the data which can be used for the benefit of the business and gaining a competitive advantage? So analytics skills and data skills are no longer nice to have skill. They are an essential business skill. So for all of you who are working in any role in any organization, this is an essential skill. You need to have the ability to work with data and appreciate what the data can give you in terms of insight into the business. So what is analytics then? So analytics, in a very simple manner or in a very plain definition, is a systematic and structured approach that combines data with the knowledge of process, domain, and technology. I know I'm throwing a lot of words here, but what it means is that using data along with the knowledge of the process and the domain to develop applications that give benefit to the business is analytics. So is there really a demand, or is it something which is a lot of hype created around it? No, there is no hype. There is actual demand. And if you look at some of the headlines that I have quoted here, the Gartner report says there will be 4.4 million jobs worldwide by 2015, and 2015 is just a month away. So you can look at the quantum of opportunity that we are looking at. Hindu says that the analytics firms in India specifically will face a shortage of 2 lakh data scientists. So just these headlines alone can tell you what is the magnitude of the requirement we are talking about. So who is this course targeted at? Who should be taking this course? Well, this course is an entry-level course, and as you see from the name of the course, it's a fundamental course. It's a foundation course. This is a course meant for anyone who wants to start a career in analytics, or if you're already a working professional and you want to make a switch into analytics. This course will help you get those basic foundational skills that will help you make that transition, or that will help you get into this career. It is also a primer or basic course for people who wish to pursue advanced courses in data science, machine learning, or big data analytics. So this is the the first step towards becoming an analytics professional. So what will this course cover? What are the content topics? As I said, this is a foundation course, so we will cover starting from the basics to some of the more advanced topics. We will cover the entire spectrum of analytics. So we will start first with data. Data is the foundation for analytics. So as an analytics professional, you need to understand everything about data. What are the data types? What is the architecture of data? How do you extract and summarize data? How do you explore the data? Visualization of the data, and eventually the transformation of this data into an insight for the benefit of the business. We will study statistics, which is a very integral part of data analysis and analytics. We will explore descriptive and inferential statistics. Moving on from statistics, we will also cover data mining algorithms and techniques for predictive modeling. The analytical tool environment that we'll be exposed to in the course will be R programming language and Tableau for data visualization. So those are the key content areas that we covered in the course. So why SkillSpeed? What's SkillSpeed's value proposition? How is this different from anyone else out there who's offering the course? The course has been designed by industry experts. I bring in my 12 plus years of experience in the industry, of having been an analyst myself and then having managed teams, hired, trained. So I bring the needs from the industry, and that's how the course has been designed. All your sessions will be instructor-led virtual sessions. Case studies that will be discussed will be real life, so that you can take back the concepts directly to your workplace and apply them. The interactions will be live with the industry experts. You will also get a lifetime access to all our content through our learning management system. There will be a 24/7 support that will be available to you, and we will also do placement support. So with that introduction about SkillSpeed, we will start our first session today, which is an introductory session on analytics. Before that, I would like to quickly kind of answer, put some ground rules for our session. Please post your questions as I am, talking and presenting. Whatever questions you have, please post them, and I will answer them either during the session, or I will take time out at the end of the session to answer all your questions. In case there is the questions don't get answered, please send them to analytics@skillspeed.com, and we will assist you and get the questions answered. So there is a question here from one of the participants, Vikas, and he had a question, what if my queries are not answered? What should I do? So Vikas, the answer to that is you could either reach out to our 24/7 helpline, where there will be suitable assistance available to you. These people will address any of the queries that were not answered in the session, or any doubts you have related to the session as well will be answered. In case the help desk is not able to resolve it, the SME, it will be escalated to the SME, and the SME will answer it for you. So hopefully, Vikas, that addresses your question. All right. We will get started with our session for today. So, like I described, analytics is an emerging field, and there is there is a lot of different words that are out there in the context of analytics. Let me tell you a simple story. When I joined G Capital on the first day of my introductory session in the organization, I had to meet a host of people, and everyone was talking with a lot of jargon, and there were a lot of terminologies that were floating, and I was totally ignorant of all of that. And at the end of the day, I had a massive headache because I did not understand what language the people in that organization were talking. So I opened an Excel sheet and I started typing out all the things I had heard and demystifying those words to myself and making it more simpler to understand for myself. So this is a challenge for anyone. When you enter a new new area, a lot of the words seem very mysterious and they seem like very complex. So this session today, the intent of this session is to demystify the jargon, make them simpler, make them something understandable, so that from here on, as you get into the course, these terminologies will be very clear and there will be no doubt about these terminologies. We will also try to understand some of the myth versus reality associated with analytics and the terminologies therein. All right. So before we moving to actually looking at all the terminologies and their definitions, what I would like to do is introduce you to a case study here, and we will use this case study as the example to understand all the jargon associated with analytics. So the case study here is of a company called Vanity Cosmetics. Vanity Cosmetics is a beauty care and personal care product company. They are right now a Canadian-based company and they want to expand into global markets. And they feel that analytics is an area they need to focus to be able to do the expansion of their organization. Their CEO recently attended a conference where one of the key strategic points that was discussed was how analytics can be used for gaining competitive advantage. And he's very enthused about the whole thing, and he asked his team to start putting a strategy for analytics. Now the Vanity team needs to understand what are the different aspects of analytics and what are the terminologies, what is the landscape of analytics. So let's look at what is the landscape of analytics. The foundation. Data is the foundation for the roadmap to analytics. And all organizations need to have a robust data architecture to be able to do analytics. So if you look at the figure described here, it's a very high-level illustration of what an organization's data architecture should look like. This hides all the complexity. The data architecture is fairly complex, but I have tried to compress all of that into three simple areas. So the first area is the source systems. So these are the systems that generate the data. This is the data generation point. So you could have transaction systems, you could have operation systems, you could have point of sale, you could have devices, and in the recent past, the social media is again a huge source where data gets generated. Now all this data is really in its raw form, and it is not something that one can use for analysis or drawing intelligent insights. So this needs to be processed, this needs to be put in a shape and a form where then one can use it for transformation to insight. So this is the pre-processing stage, and your ETL systems, your data quality systems, all of those come here. And then finally the transformed data. So once you have the data in a form that it can be analyzed, it can be summarized, you then build into transformed data, and the transformed data could be in the form of management information systems, it could be in the form of online analytic processing systems, it could be analytics, so it could be a host of things. So data from its raw form is now transformed into something which is meaningful, relevant, and intelligent for the organization to use, and they can derive the benefit out of it. So this is a foundation. This is the high-level architecture that any organization needs to have for using and developing analytics. So let's look at the first step towards an organization's ability to derive insight from data. The first jargon or the terminology that we are going to talk about is business intelligence. So what is business intelligence? So business intelligence is the transformation of data to generate meaningful, relevant, and actionable intelligence about the business. So business intelligence addresses an organization's needs to answer what happened. So what is the status of my business? Where am I? How many, how often, and where are the transactions happening? What exactly is the problem? So what are the trends and alerts associated with my organization's processes and systems? What actions are needed? And these are key performance indicators. So what do I need to do? So knowing what's happened in my organization, what do I need to do next? Am I on target? So all of this is really a decision system, and if you look at BI, it has evolved really from the decision support systems and OLAP systems. So the spectrum of business intelligence includes starting from basic standard reports, which are operational metrics and transaction summaries. Dashboards, like a car dashboard, these are dashboards that give an aggregated view of the business portfolio. The diagnostics, key measures of performance, comparative views, scorecards for performance, trends and alerts. And this kind of summarizes the portfolio and helps the managers and the decision makers know what's happening with their business. Often the dashboards themselves lead to further questions which are not answered by the standard reports. And here is where the need for developing more ad hoc reports come into a picture. So the ad hoc reports are essentially interactive views of data. They drill down, slice and dice, because here there is an alert and I want to investigate what's happening, so I get deeper into the data. And these are one-off kind of reports. And then finally data visualization and summaries. So data visualization and summary includes charts, infographics, interactive visuals, storytelling with data, and so on. I have a question which Ms. Neha has asked. She wants to know if data visualization is just a reporting mechanism, or it can also be used for further exploration of data. That's a very good question, Neha. And data visualization is an extremely important tool today. This is not only used for traditional reporting of data, but it is also used, so it's no longer just the bar charts and the pie charts, but it's much more. And especially in the context of big data, when there is large volumes of data and you want the first step to understanding the data, the visualization of this data is becoming very important. You just go and search data visualization, and you'll see there is a wealth of information available on, and this is an extremely emerging area, and a lot of work is happening in this area. So thank you, Neha, for asking that question. So data visualization is something that we will be covering extensively in this course as well. All right. So let's look at what business intelligence looks like for our case study, Vanity Cosmetics. So the first example out there on the top of the presentation is a daily sales report. What a daily sales report does is, by region, it gives me the dollar sales and the percentage sales. So if I am the sales head and I want to know quickly what's happened across the different regions, this is a simple summary that I get on my BlackBerry, and I know what's happening with each of these regions. Let's look at what a summary report or an aggregated dashboard looks like. And this is a snapshot of a KPI summary report. And this talks about the finance metrics. And if you look at what it does, it on a monthly basis, it summarizes the metrics. And then it gives the last 3-month average, 12-month average, and it also gives a comparison against the target for the month. So the target for the month for revenues was $18,000 dollars, and we've actually done a little better than that. So we are green. So KPI dashboard, if I'm the manager of this business, or I'm the CEO of this business, looking at these numbers tell me where do I need to focus my attention, and where am I doing okay as a business. Great. The next terminology, and this is actually, you'll see when I summarize this for you, this is an increasing level of what the insight and the intelligence we can get out of these different analysis options. Data analysis answers the key question of why is this happening. So if you look at BI, it was trying to summarize the what and the status, and you know, this now gets into the realm of understanding why this is happening. So data analysis is primarily done for events that have already occurred, and the data is available for the same. Statistics is the cornerstone for data analysis, and we will be covering a lot of the basic statistics as well as in this course. So statistics is the cornerstone for the data analysis. The nature of data analysis can be of two types: descriptive, which uses data to describe why events have occurred, and inferential or confirmatory, which use data to infer or confirm assumption about relationship between data or events. So let me just move on here. There are two different types of data analysis, and this is based on the data that is available. So data can be quantitative or qualitative. So when I say quantitative data, this is primarily numeric data, and the analysis of numerical data is done using statistical techniques. And like I said previously, there are two types of statistical analysis: descriptive statistics and inferential statistics. When we say descriptive statistics, it's primarily covering measures of central tendency and variability. When we talk about inferential statistics, it's hypothesis testing and estimation. Qualitative data analysis is really analysis of non-numerical data, and data can be of multiple types and shapes. So data could come in as textual, documents, reports, letters, narratives, which could include interviews, audio recordings, visual data. So in these contexts, statistical techniques are not applicable, but mostly the SMEs do the analysis from their knowledge and experience. It is subjective and judgmental in nature, and this is an area where there is a lot of research happening as well, and how this can be not a judgmental process, but actually the machines can do the analysis of the qualitative data. So let's look at what data analysis means in the context of vanity cosmetics. So from the monthly KPI dashboard, it was observed that there was a lot of variation in sales from the stores in the Richmond region. Now, whoever was reviewing this dashboard wanted to know why was this variation happening. So they went deeper into the data, and a simple histogram revealed that 25% of the sales representatives sold less than 15 units or less in the last month. And all right, so there is this problem spot right there, and they wanted to know why this happened. So further analysis from the field reports revealed that the competitor was running a sale, 50% sale, and that impacted the performance of the sales representative. So you can see how we are now getting better and better insights with each step into the data. So the initial data gave us a sense for where vanity cosmetics was doing, and now actually we have dug deeper into one of the problem areas and identified what specifically is the problem in the business. Data mining. So data mining, my favorite definition of all this is really the second one, which says non-trivial extraction of implicit, previously unknown, and potentially useful information from data. Great. I mean, there's so many words out there. All right, let me explain each one of them. So non-trivial extraction. So data mining attempts to extract information which is useful, so it's not trivial information, and it is also not explicit, it is implicit, it's inside the data. So that's why it's called data mining. We are mining inside the data to find something that is not explicitly known. It was not known, and the mining process helped us identify those patterns from the data. And these patterns should be useful information for the business, otherwise they again become trivial, and there is no use for these, and the business cannot benefit from them. So when there are large quantities of data, how do you go into the data and find those useful patterns? And that process of finding those useful patterns is really data mining. When we talk about data mining, immediately machine learning, also comes up out there. So what is machine learning? So machine learning is really a branch of artificial intelligence that deals with construction and study of systems that can be learned from data. So the machine learning primarily focuses on prediction based on learning from the past data. So what does that mean? So what that means is that if you tell the computer function of x is equal to y 1,000 times, and now if you give a new value p, it is able to estimate f of p and give you that output. What machine learning is not is your computer's ability to do arithmetic calculations. So if you give two large numbers to your computer and ask for them to be multiplied, or you give two matrices and ask the computer to multiply the matrices, that is really not machine learning. Another example could be training the machine to recognize spam mails so that they can be removed automatically into a spam folder. So the machine learns the rules for recognizing the spam, and it automatically transferred those spam mails into a separate folder. What it's not, again, is your computer's ability to compile programs to create exe files. So I have those examples kind of help you understand what machine learning is and what it is not. So let's look at what data mining would do for Vanity Cosmetics. So Vanity Cosmetics wants to launch a new range of herbal beauty care products and wants to understand the customer segments. So when we talk about customer segments, essentially Vanity Cosmetics has a huge customer base. So it could be they could be entering into a new geography. Let's say they are coming to China, and they have the database of all Chinese women, and now they want to understand if there are specific needs and there are specific groups within these big population. And here is where data mining goes into the data to identify those patterns and group the people into homogeneous groups, which could be then treated differently. So in this case, the data mining for segmentation really kind of came up with 5 different segments for Vanity Cosmetics. So the buyers are categorized based on their behaviors, their lifestyles, their needs from this product. So let me describe one of them or two of them. So price sensitive buyer. So this is a buyer who's very price sensitive. She does not like to spend too much money, or she rather wants to evaluate her options and then choose the best option which she can afford from her wallet. Then there is a buyer who is a vanity buyer. So these are buyers who are extremely vain and who want to buy products that will make them look much better. So if you brought a celebrity endorsement for your product, maybe this is a group that will go and buy the product because they want to look like the celebrity. So you could have different strategies for each of these segments, and that is how organizations use data mining to identify the patterns. So now coming to the key definition, which is all what this course is all about, is analytics. So what is analytics? So analytics is really discovering, understanding, and enriching the understanding of the historical data to both describe what's happened in the past and use that information to predict and improve future business performance. And the patterns of data are not recognized in isolation. So analytics is an all-encompassing term, as it includes from the basics of business intelligence, where you understand the current status quo of the business; OLAP, where you can slice and dice information, get deeper into a problem area; you use statistical analysis to define what happened; and it also uses machine learning techniques, data mining techniques. So the analytics is an umbrella term which is used for everything that has to do with working with data for deriving the insight into business performance. All right. The types of analytics are descriptive, confirmatory, exploratory, predictive, and prescriptive. So descriptive describes the problem. Confirmatory confirms the hypothesis about the problem. Exploratory, you don't know anything about the problem and then you let the data tell you what the problems are. Predictive, you use past performance to predict what the future will look like. Prescriptive, you just don't want to predict what the future will look like, but you also want to know what the best future should look like. What is the best route to get to the future? So during the course, we will be covering all of these types of analytics through various case studies, etc. So let's look at what analytics for the case study Vanity Cosmetics looks like. So you saw in our previous data mining exercise, we had developed customer segments. And now Vanity Cosmetics wants to run an email campaign asking these women to visit the stores for a special promotion. So a response model is built, and a response model essentially means a model that will predict the likelihood of somebody responding to this email campaign. So it predicts the likelihood of response. And the model uses historical data, past campaign data, demographic and psychographic data to identify the attributes. What are the attributes of the women that are being targeted, which can predict response. And then the model is used to run a targeted campaign for the herbal beauty care range. And if you look at the results that the company gets out of this, so a response rate of 40% is observed in the first 2 weeks of the campaign, which is significantly higher than the previous campaigns. So if Vanity Cosmetics had not used analytics and developed a response model, and if they had randomly mailed X number of women, they would not have got this response. All their previous campaigns were random campaigns, but this is a targeted campaign, and you can see the difference in the response rates. So this is the power of analytics. How can you make your decisions better and better? And the data is available, so how can you make the data work for you to improve your decision process? Data science. So this is a new terminology, and if you had looked at some of the headlines, it says the data scientist is the sexiest job in the current decade. So what does data science mean, and how is it different from analytics? So well, data science is not very different from analytics in the term that it kind of looks at all of those elements that we saw in analytics. There's machine learning, there's statistical analysis, there's data visualization, there is mathematics, pattern recognition. One of the key elements here that you need to look at is the high performance computing. And the reason why data science as a field has emerged is because we are talking about data which is not the traditional structured data, but data which is structured, unstructured, and semi-structured. So when we say structured, unstructured, and semi-structured, it's really the entire gamut of data, and the term today used is big data. So in the context of big data, it is also required, the computing of this data is also of key importance. So data science combines all of these, and so anytime somebody tells you data science, that's what the difference is. So you need to have the ability or the skill to even compute that large volume of data before you can do any analysis. And if you remember previously, we had one question where Neha had asked us about visualization. And if you see here, visualization is a big part of data science. It is very, very helpful in exploring big data and understanding, the first level understanding of big data can happen with visualization. All right. There you go. Let's summarize our jargon or the terminologies that we have studied so far. And what I have done really is a value chain for you. All the terms that we understood so far are all connected to analytics. And the way they are connected to analytics is really through the value chain. So the value chain, the two axes here are the business value and the degree of intelligence. So as the degree of intelligence increases, the value that business can get out of this also increases. So if you see, the first step is really the understanding of the relations within the organization's processes and systems. What happened, how, what is the problem, what actions are needed, and that's where your reporting and MIS and BI, all of that comes into picture. The next step is, what are the patterns? So why is this happening? Will these trends continue? What will happen next? And that talks about your data mining, your statistical analysis, your predictive modeling. And then finally, the what best can happen. What is the optimization? How do I understand the underlying principles? So let's take the example of, social media example to kind of help you understand this level of intelligence and the value, right? So Facebook, let me take the example of Facebook. So if I see a report which says Facebook had, 1 million users, and there were, people log in every second onto Facebook. So this is just giving me a view of basic operational metrics for Facebook, right? The next level, which says that the age group 18 to 20 will respond to a product like a smartphone. So if you are wanting to, if you're a smartphone manufacturer and you want to advertise on Facebook, you want to know exactly what target group will look at Facebook ad and respond. So that gets into understanding the patterns. What are the patterns? What are the connections, right? And then finally the underlying principles. So who uses, how best can I use Facebook in my overall digital marketing strategy? So that's understanding the underlying principles. So that in a nutshell is really all the terminologies associated with the analytics and the value chain, how all of these fit together, and what is the intelligence and insight that each of these steps gives us. So I hope, at the end of this session, you are clear in terms of terminology and your journey into analytics and how each of these areas is relevant for your journey in analytics. All right. Next, in this session, what I would also like to do is give you an introduction to the R programming environment. This is the environment we will be using for all our analysis. So it's a comprehensive environment where you can do statistical analysis, graphical analysis, as well as all your data mining algorithms. It's an open source platform. And if you are somebody who's very interested in programming and wants to explore this further, go ahead and you could create your own libraries of functions that you have written in R and make it available to others. So the way we will run this R session is, all right, I see a question here from Megha. Megha says, are we going to see a demo of the R, or will we get to see how the environment looks like? Yes, the answer to that is yes. I will actually open my R window and demonstrate to you the different functions in R and how one can use R for doing all the different type of analysis that we have spoken so far. What I want to do today is, because this is an introductory session, do a quick demo of some of the plots in R, show you how you can plot your data for data analysis and interpretation. All right. So I hope you can see my screen on which opens up into RStudio. So if you are seeing my screen for the RStudio, let me kind of describe you the 4 windows that are open here. The window on the left top corner gives the data. So right now I have a data set open which has car names and some car characteristics. And then I have the console window on the left bottom, and on the right top I have the environment and history information. So the history gives me all the different codes that I have been running, and the environment gives me the global environment picture. On the right bottom corner I have a window which gives me the files, the plots, packages. Packages are nothing but libraries that I can import. There is a help window available where I can type in so any help that I need. So let's say I want to find out about histograms, so it gives me what are the options and I can view those. All right, so the first step here is, let me kind of explain this data set to you. I have a data set called the automobile empty cars, and it has information about cars, miles per gallon, the type of cylinder, number of cylinders, what is the HP, and so on. So there are different parameters of a car, and what we will be doing is we will run a couple of graphs, and I will demonstrate how these graphs can be used for analyzing the data. So what I have done for myself is it's always a good idea to open a notepad and type the commands before you bring them onto your console. So let's say I just want to understand the miles per gallon, and I could do a descriptive summary. I could say summary of empty cars $mpg, and what it will give me is it will give me the basic statistical summary, the mean, median, and the quartiles, and the min and the max. So now I don't care so much right now to get into the statistics, but I actually just want to look at a graphical summary. What I could do is I could do a histogram of this variable. So I say hist, and there you go. If you see my corner here, let me zoom this for you. So if you see, it has plotted a histogram of the MPG, miles per gallon. And when we say histogram, histogram is nothing but a frequency chart, and it plots a frequency chart. Now this is looking a little plain. I want to add some color to this chart. So what I do is I add color to this chart. All right, there you go. Now you see I have a little color to my chart, and I am not so satisfied even with this. I actually now want to do a little bit more with this data. I want to plot a normal probability curve around this. I want to have a normal curve, and I want to see how this data, whether this data is normal, non-normal. So what I do is I fit a normal curve, and if you see there, let me zoom this for you. So if you see, now it's fitting a normal curve. It's fitting a smooth line into the histogram, the frequency chart. So this tells me the shape of my data. Is my data having a problem of variation? Is my data having a problem of center? What is the problem? So if you look at the data here, there is quite a bit of variation in my data. So the visual elements of the data can be used for understanding what's happening with the data. So I also want to know, maybe histogram is not such a great tool. It's not really helping me kind of figure out what's happening with data. I could use a density plot. So what the density plot does is it actually gives me the density or the concentration of my data, and it tells me where is majority of my data concentrated. Very interesting, but it looks a little boring, so I could add a little bit of a color to it. So let me add a little bit of a color to my density plot, and what could happen is, bingo, there you see. You have a density plot which is colored, and I have also given a blue outline to the shape. So this looks much better in terms of your ability to interpret and understand this data. There is another type of plot that can be used, which are called the scatter plots. Scatter plots are used when you want to compare two different variables, and these two variables are continuous data types, and you want to get a comparison of and understand the relationship between two variables. So for example, I want to compare the relationship between miles per gallon and the weight. So both of them are continuous variables, and I want to see if there is a relationship, right? Is there a relationship between the miles per gallon and the weight, car weight? So let me do that. Let me draw a plot of these two. And what you will see here is you will see that there is a relationship, and it's a negative relationship. So miles per gallon decreases as the car weight increases. So if your car weight, a lightweight car will have better miles per gallon. And this is true. I mean, if you follow the car industry, you'll see that the small cars have a better mileage than the bulky SUVs. So let's kind of look at how can we put a line to understand the relationship. I want to fit a line, a linear line, and see the relationship. So what I could do is I could, in the same scatter plot, add a line, and that line will tell me, let's see what this looks like. So there you go. So I added a line, and this now shows me the, the fitting into the scatter plot. So there is a lot of different, playing around that we can do in R, and in your course you will be given a lot of data sets to experiment and play around with it. So let's look at another kind of a scatter plot. So let me zoom this in. So this is an enhanced scatter plot, and it tries to see, what is the distance by categories. It tries to fit the smoothen the plots, and all this will help you as you try to interpret your data and find the. So here my variable that I'm trying to understand is miles per gallon, and I want to understand all the variables that impact miles per gallon, and these are all the visual ways in which I could start making sense of this data. So let me show you another type of scatter plot, and what this does is it plots the relationship of miles per gallon with 3 different data points with disp, grat, and weight. So if you have multiple variables and you want to look at the relationship with your class variable, you could use a scatter plot matrix, and that will give you at one shot all the information that you need. All right, so let me go into another quick one here before we kind of. So I want to look at a scatter plot in 3 dimensions. So 2-dimensional data sometimes may not give you all the picture, and you want to do a 3D plot. So let's see what a 3D plot looks like. And here you go. So this is my 3D plot, and in 3 dimensions, when I have miles per gallon, I have weight, and I have this. When I want to look at the relationship between these 3 plots, I could have a 3-dimensional scatter plot. Great. All right. I think I have one more to show here. Yeah, I also want to show you something which is the box plot, which is also used very much in analysis, visual analysis of data. So let me show you a box plot here. So there you go. So I want to look at number of cylinders and the miles per gallon. And if you look at 4, 6, 8, those are the 3 categories of cylinders I have, and I want to know what's happening. So if you look at the 4 cylinders, you'll see there's a lot of variation and compared to the other 2. So in 6 and 8, the variation is much lower, whereas in 4, there is the spread of the data is quite vast. Very interesting. All right. I will also show you another commonly used chart, which is the pie chart. Let me just create a data and show you how we can create a pie chart. So there you go. I have created a simple pie chart which has a pie chart of sales by different categories of apparel. And this is the, mind you, this is just an introductory session, so I have given you some simple examples of what we can do in R. But R is an exhaustive environment, and there is it has a lot of capabilities, and it's a lot of fun to explore data and experiment and understand data. So all the exercises that you will be given and the assignments will be given will help you kind of explore this on your own. I also urge you to take different data that are publicly available and experiment with R. Thank you so much for attending this session. It was a pleasure having you all in the class today, and we will meet again for our next session next week. If there were any questions that were unanswered in the session today, please drop an email to analytics@skillspeed.com, or also, you could also call in our helpline, and somebody will answer these queries for you. Thank you.